Hello, my name is Dave Carmichael. I'm a solutions engineer with the RS technical support team. Bearing failures are one of the biggest causes of downtime and one of the most mishandled causes. In this video, we're going to discuss root cause analysis as a method of reducing downtime. In most cases, when a bearing fails, the initial reaction is to replace the bearing, as it's the cheapest and usually the easiest component to change. This isn't necessarily the cheapest long-term solution. What happens in industry is a machine fails or a piece of plant goes down. The first thing is, usually it's a bearing that goes, and the first thing is we're going to change the bearing. Changing the bearing is not necessarily the right thing to do. There are various causes for a bearing to fail, and some of them are caused by other parts because the bearing is the weakest link or the smallest link in the chain. When you remove the bearing, the older bearing has worked and caused wear and settling of the housing and the shaft. This is indicated by black marks on the outer ring or on the inner ring. If you put a new bearing in on that existing housing and shaft, it will try and conform to that pattern, which will put extra stresses on the inside, and the bearing will fail quicker than the previous bearing. And that will happen continuously, just worse and worse. So you need to check shaft and housing to make sure that they are clean and there's no wear apparent. If there is wear apparent, you need to change the housing or the shaft, whichever the wear is on. If you have a self-aligning arrangement such as this, obviously the optimum is to get both bearings centered and straight with the housing. If for some reason your footing is off, you can have the housing offset, but the shaft bearing to bearing must be dead straight. If the shaft is bent, then the bearing will wobble, and that will cause the outer ring to move in the housing, which is not designed to do. The evidence of that is cast iron below the housing. Once you see cast iron or you see a shaft that is wobbling, you need to change the whole unit, housing and bearing. When a bearing fails, it is generally a symptom of something greater. Is the shaft bent? Is it misaligned to the coupling, actually vertically and parallel? Is the motor shaft straight? Are the motor bearings good? Is the motor seating correct? Are the nuts and bolts tightened down? Can it move? Those are the things we need to look at in the drivetrain. If your piece of plant is a fan, the fan has issues all of its own. And the biggest one is whether it's pushing air or a product, the product or the dust in the air collects on the vanes. This causes imbalance, which causes vibration, which then goes down to the bearing and will cause the bearing to fail, but as a symptom of that imbalance. One of the principles of a bearing is that it must be run under load. If you have a jack shaft with two or more bearings in a line, and one of the bearings is not being loaded, in other words, it's floating, that bearing will fail as well because it needs to be under load. This is a bearing analyzer, and it is used to detect vibrations within a bearing when a vibration has been felt or heard on a machine but not specifically where. The analyzer can be moved to various positions in the machine. Where you find the highest reading is where you're going to find your most probable cause of a problem. Having discussed a handheld monitoring system, you get complete systems which look after the whole machine. These systems have a green, yellow, red traffic light warning system. It's preferable to look at yellow, not wait until it gets to red. If it gets to red, you may already have consequential damage to some other parts of the equipment. If you've had a bearing failure, and perhaps it's failed a few times, it may be suggested that a more robust or bigger bearing would fix the problem. It may very well fix it in that position, but remember that we're looking at the weakest link in a chain. If you make that link stronger, the next link may be more expensive to repair than the bearing. That covers the importance of root cause analysis. I hope you enjoyed this video, and if you did, please check out our other how-to videos on YouTube.